So this video is for Math 70, and this is for the assignment on the introduction to word problems. Hopefully you've seen some of this material before. When it comes to translating between word problems and mathematical notation, these are some of the building blocks for things that we can work with. What this builds up to are actual mathematical applications which typically involve the world around us. Physics and chemistry and biology. All of the experiments that these scientists typically do, frequently what they're researching are mathematical relationships between things in the environment. Okay, so these are building blocks to help us approach that style of applying mathematics to the natural world. Okay, so first off, our four operations: add, subtract, multiply, and divide. Here's some language that matches up to each of these operations. Some of it's obvious. Some of it hopefully will become more obvious as you work through the problems. Oh, and I left out an important one here. It's not an operation, but it's an important mathematical symbol, and the word is typically denotes equality or an equal sign. Okay? All right, let's look at some of the problems in here. We start off with just expressions, which means no equal sign, okay? And then at the bottom of the first page, we switch over into equations. So, starting with problem 2, we've got 4 times a number. Well, I think most of us are familiar with the language there, so we could call this 4x. You could call it 4n. The variable at this point doesn't really matter very much. If you put the symbol in there, times, that's okay, but most of the time people just leave the symbol out. And another thing is, when it comes to algebra, once we start using x a lot, don't use this symbol for times, okay? Right? That's not what we want to do in algebra. That's why we start using the star symbol. A lot of textbooks use a dot, which is fine. I find the dot, people sometimes mistake it for a decimal point, or it can be hard to see. That's why I use the star symbol to mean times. Okay, let's see here. Problem 4. We've got the sum of 3 and a number. Okay, so sum means we're adding, and so you could call this 3 plus x. You could also call it x plus 3. They're both the same thing. Now that's not going to be true with subtraction, right? Subtraction is not commutative, so it's important what comes first and what comes second when we're doing subtraction. In addition, not important. Okay. Problem 6. A number increased by 10. All right. Increased by more addition. So our number is getting increased by 10. Okay, now, before I do problem 8, I want to talk a little bit about this phrase less than. Okay, you can see it here listed under the subtraction language. So let's look at an example of less than. Let's see here. Let me do one first that's not algebra. Okay, we know that 3 is 7 less than 10. Okay? Now, if we wanted to write this in mathematically, 7 less than 10. So 3 is, I'm getting into the equations already, but in any event, this phrase 7 less than 10, now, if you just translate it directly, you'll have a 7. You'll say, oh, less than, that means subtraction, and then 10. Is that correct, though? Is 3 equal to 7 minus 10? No, it's not. Okay? 3 is equal to 10 minus 7. So when you see something less than something else, that typically means this minus this, okay? If you see A is 4 less than B, this phrase right here is B minus 4, okay? So that's an important thing to remember. A lot of people forget it, and they write their equations backwards. So that's why I'm taking the time right now to talk to you about this and encourage you to remember how this works. Okay? All right. Now let's go back and look at, pick up where we left off here with problem 8. 5 less than 9 times a number. Okay? When you see 5 less than, that's going to mean something minus 5. Okay? The 5 is going to come last. And what is it less than? 9 times a number. 9x minus 5. All right. Let's keep going here. 8 more than 1/3 of a number. Now, with more than and addition, it doesn't matter. You can just translate this directly. 8 plus 1/3 times x. Or you can call it 1/3 times x plus 8. It doesn't matter because addition is commutative. Okay? In subtraction, it does make a difference, and it's important to get that correct. Problem 12, 10 times the sum of a number and 9. So let me write this out. 10 times the sum of a number and 9. Okay. So we know that we're going to multiply 10 times something. Okay. When you see this language, the sum of, 10 times the sum of, you should think parentheses, all right? Because the 10 is going to get multiplied by the sum of a number plus 9, all right? So there it is, 10 times the sum of a number and 9. All right, let's see here. Problem 14. Problem 14 is very much like problem 12. So in problem 14 we've got 1/2 the sum of a number and 5. So we're going to have the sum of a number and 5, and then we want to multiply it by 1/2. Now you can also divide it by 2 if you want. 1/2 the sum of a number and 5. You can write it like that also. Okay, those are both correct. All right, so those are some building blocks to get us started with these problems. Now let's switch over to the equations, where we're going to have 2 sides in the equation. What those first problems that we were just practicing, that's going to be like one side in the equation, and then the other side is going to be something very much like it as well. Although in problem 16, the first couple problems, the other side is just a number. So problem 16, 3 less than 4 times a number is 8. Okay, so here's your is, that's the equal sign. One side of the equal sign is going to be 8. The other side is going to be 3 less than 4 times a number. Remember, if you see 3 less than, you should be thinking something minus 3. What are we going to subtract 3 from? 4 times a number. So there's our equation. 3 less than 4 times a number is 8. So now we just need to solve it. So 4x is 11. And x is going to be 11/4. You can leave it like that if you'd like. It's also, I believe, 2.75. Okay, so that's problem 16. Problem 18. 20 more than 3 times a number. Okay. Is what? 53. Okay. So 20 more than 3 times a number is 53. Okay? So here's your more than. Here's your is. Here's 3 times a number. And there's our 20. Okay? So it's all there. Now we have to solve it. Now you could have written it 3x plus 20 equals 53. Remember, with the addition, it doesn't matter what order they're in, because it's the same thing either way. Okay? So in any event, to solve this equation, we're going to subtract 20 on both sides, divide on both sides by 3, and here, x is equal to 11. All right, that's problem 18. Problem 20. I'm going to stop writing these down as they get longer and just translate them directly off the page. Okay. 12 times the quantity. Now that's like 12 times the sum of, okay? So we're going to be thinking parentheses on that one, okay? The quantity 4 more than 6 times a number is 60. So there's our is, there's our equal sign. 12 times the quantity, 4 more than 6 times a number. 4 more than 6 times a number. And you can write it 4 plus 6x or 6x plus 4, because it doesn't matter if you're adding, but in the subtraction, it does. Okay? All right, so there's problem 20. 12 times the quantity, 4 more than 6 times a number, is 60. So now we'll solve this. We'll distribute. 48 plus 72x is 60. Subtract on both sides. 48. That should give us, 12. And then again, don't fall into that trap. A lot of people see the 72 and the 12 and they get scared and they're like, oh, I better divide by 12 here. No. That's not what you want to do. You have to get the x by itself, and so you have to divide by whatever is in front of the x. So here, x is going to be 1/6. If you just do 12 divided by 72 on your calculator, you'll get a 0.16 repeating, with just the 6 repeating, not the 1, like that, okay? Which is equivalent to 1/6. Either way, both of these answers are correct. Okay. And this is the kind of, this type of equation is something that would be difficult to solve without algebra. Okay? Some of these algebraic problems, you know, there is a number that is 4 more than 7. It's like, oh, it's 11, you know. You don't need algebra to solve it, but doing those types of problems using algebra, I think, is good practice so that we build up to the more difficult problems. I see that constantly when I'm teaching word problems. People want to solve them in their head. They don't want to use the algebra. Then when we get to the difficult problems, they're just like, oh, I can't do this. It's like, that's because you didn't learn the methods for doing it. Okay? So that's what we're going over here. And what I'm talking about here is that this is a good example of a problem that would be difficult to solve without algebra. Okay? I mean, there's no indication that this number that we're talking about was a fraction to begin with. Okay? But as it turns out, that is the case. And, you know, in solving a lot of application problems over the years, I find that the tools of algebra are very, very helpful. Okay, so there's problem 20. Let's see here. Problem 22. 9 times the sum of. Okay, so we should be thinking parentheses. Problem 22. 9 times the sum of a number and 4. So there we go, x plus 4, is the same as 3 more than 6 times the number. So 3 more than 6 times the number. And again, you can write it 3 plus 6x as well. That's the same thing. All right, so there's our equation. It's got 2 sides. Let's distribute this to get us started. And then I'll subtract 6x on both sides. And then subtract 36. 3x is negative 33. And so x is negative 11. Let's see here. Got 2 more of these on here. All right, problem 24. 8 more than 3 times a number. Okay. 8 more than 3 times a number. I'm in the habit of writing it like this, just because it's important to do that when we're doing less than. So I do it for both less than and more than. Let's see here, 24. 3 times a number is the same as the product of 4 and 1 less than the number. So the product of 4 and 1 less than the number. Okay, so we need parentheses here. And there we go. 8 more than 3 times the number is the same as the product of 4 and 1 less than the number. Okay. Okay, so let's distribute 4x minus 4. 3x plus 8, so we'll subtract 3x on both sides, and then add 4 to both sides. X equals 12. Okay, that's problem 24. We got 1 more on here. Problem 26. 4 times a number is added to 8. Okay, that's pretty straightforward. 4 times a number added to 8. The result is, that's another equals to over here. The result is 3 times the number added to 5. Okay, pretty straightforward. Subtract 3x on both sides. And then subtract 8 on both sides. And so x is negative 3. Okay, so that's it for this introductory assignment. I encourage you to go through here and do the odd problems. The next assignment will have specific types of word problems, some common types of word problems like mixture problems, which you just see in a lot of different places. I'll talk more about that when I make a video for that assignment. As always, if you have any questions about this, please let me know. Thanks.